Welcome to everyone. My name is Janne Nummela and I'm working as an application specialist for Cadmatic, and I will be hosting this webinar today. Please mute your microphone, and for keeping the schedule, type in your questions. We have reserved some time for answering questions at the end of the presentation. Cadmatic is a software house developing tools for improving business performance by means of modern design and information management technology to our customers, which are engineering consultants, EPCs, and owner-operators. We have main offices in Finland and at the Netherlands, and also some personnel in Russia, China, India, Italy, Hungary, Singapore, and United Arab Emirates. We have over 900 customers organizations in 16 countries and thousands of successfully completed projects in different industries. You can find our customers in different industrial segments, where EPCs are about 17%, owner-operators 27%, and engineering consultants 57%. We have customers at bio, pharma, food industries, power energy, pulp and paper, marine and offshore, oil and gas, and also at chemical industries. Our webinar today will include P&I diagrams, layout design, piping design, piping isometrics, drawing generation, and material takeoffs. Right. Now we are ready to start with the demonstration. I will start with our diagram. When you're creating a new pipe at the diagram, you can see the node names right here with the tank equals outlet. And next to the filter, you can see X mark indicating that there was no piping connection yet. When inserting a pump, you can see that it rotates according to flow direction. And when we set it, we can define directly the position ID according to specified rules, and we can also fill in some attributes, whatever you want. Then the label is added directly where you wish to get it. Then we make a bypass here around the pump just by drawing the line where you want it. And after adding them line, there will be needed some valves. I will search those from these templates and just insert those to the correct place. I will not give any position ID yet. I will just place the label where I need it. Next, some pipeline labels. There is not yet defined any specific pipeline data, but once the data is updated for the lines, the label will be updated correctly. Here we are. Now I will add the position ID for the valves, and the label is once again immediately updating. The second valve and third valve. If I add same position ID twice, there will be a message telling you that there's a mistake and you can fix it. In diagram, we can also define what is used 3D model so that it's easier for 3D designer just to select the correct position ID and keep the model. I can use hierarchies, but I will search it from the library. Here it is, under this one, we can find this bump. And now in 3D, there will be used exactly this 3D model. Copying data is very simple. I will add here to the connection just a W. It is shown once again at the label. And now I will copy this data from this valve. I will select what to copy, and then I will select where to copy this. And there it is. Then some example about the listings. You can easily make these valve listings, and because it is in the SQL database, we can easily refresh it when needed. Here we don't have yet anything at the connection, but after refreshing it, data is retrieved from the SQL database. And our listing is now up to date. In the model, you can pick the object and you can query data what you have. Here we can see that we have attributes coming from the diagram, like here, slurry tank as a rolling process attribute. When inserting a new equipment, I will see at the list only those position IDs which are coming from the diagram and which are not yet set to the model, so there will be less mistakes. Then I will set this pump to the correct place, first by rotating it a little bit. Then I will rotate the view a little so that I can easily set this pump to the correct place at the top level. Here we can see once again all the attributes coming from the diagram. So you need to fill in those only once. Next, I will set the foundation under this pump. I will use a standard foundation which I can find from the library. This one. It must be also first rotated a little bit, like this, and because its origin is at the middle, I have to measure exactly the same point from this pump. And after this, just tiny adjustment to the height, and there it is. Next, I will put some pipings. When selecting this connection, I will see only those lines which are really connected to this tank at the diagram, so easy to select which line to start the piping. And if there is a collision, I will see it immediately. And then just routing the pipe to the correct place. We have this route assistant showing where to go, and I can use reference points to route the pipe correctly, and then pointing to the correct direction, and then with automatic routing to the end. Parts to the pipe are coming according to the specification, so if there is a flange connection, there will be added a flange. And now this pressure side pipe routed to the end. I will use once again some reference points to head to the filter, picking a point from this elbow. Then we will point to the X direction, and let's see, we have to head to the filter. The rest of this will be just automatic routing by selecting where to go, and there it is. now I will make a bypass for this pump by measuring the correct place from this elbow, and then just make a branch. Here we can see only lines again which I can use according to the diagram, and nominal size is updating what I am selecting, and routing assistant is showing where to go. Then we will find the correct place where to make the branch again, and here it will be, and now making branch. Components are also in this case coming from specification, so now we have TPs with equal sized pipes, and here we have stop-in when we have different sized branch. Then we will select valves to be added to the pipes. Here once again I will see only valves which are coming from diagram, not others, and those are pipeline specific valves. In this case I will select the valve from the specification manually, and it is added including flanges also. I will rotate it, and here we can see the attributes. Same for the other side, second valve from the specification, and rotating it a little bit. Here it is. And the third one. Same story continues. Just selecting it from here and rotating it, and here we can see once again the attributes coming from the diagram. Then we can check from the diagram that we can see what is already inserted to the model, and those are now highlighted, and I can be sure what I'm editing if needed. At 3D model we can compare this topologically, diagram by diagram, or several diagrams at once, and here I can see that I have a mistake at the EPR system. Here at the line DP10, and if I open this one, I can see that this valve 101 should be after branch to the pipeline DP11. So we can fix it. It's simple to fix just by sliding the valve to the correct place. I will pick it. I can move the valve inside this one pipe. I can use left justifies, right justifying, or center justifies. And then I will measure a reference point 100 mm from the seam of this elbow. Same thing at the other side, and same distances. And third one. This won't go also outside this pipe. I will put this to the middle of these two elbows, and there it is. Then we can compare the topology again, and now we can find that there will not be any mistakes. All these three lines are now okay. Then I will publish an eBrowser from this model. eBrowser is a light version from the model and easy to use and easy to learn to use, so that it can be sent to anyone at the organization, and everyone can walk in and check what there is in the model, measure, query data, and so on. Then we will make some material takeoffs. It's easy to generate different kind of listings, and here's one example where is all the piping materials selected. I will use a ready-made query to this, and here you can see everything what is highlighted with white now will be added to the listing. This material list will open directly at the Excel, and we can have, for example, at the each tab, for example, pipes, elbows, piping components, standard components, and so on. Next step is making isometric. First, creating a group from all these parts that I have done today, pipeline-wise. Now when the groups are done, I will do the drawing itself. I will annotate it and show you what it looks like. Annotation will be done automatically on the behind, so I don't need to modify it at all. Here we have bedding list. Then we have the pipe itself with all the dimensioning and needed labels. Here we have the material list, including all the parts and also all the washers, nuts and bolts if needed. And then we have here a cutting list. Same for the second, and then we have the third one. All with the details. Next step is arrangement drawing. I will create a new drawing just by giving a name for it. Then I will add some attributes. These attributes will be used also in the drawing title box, so no need to write those twice, but these are just copied there. Some scaling and design phase and a revision is needed at this case. Okay, there it is, and let's open it. It's empty, so we have to create some views to it. And I will make a top view, front view, and axiomatic view. And I will pick objects what I have done today. So demonstration area, what I used. Like this. Here those are selected, and now the views are generated. Then I will assign those to the page, to the correct pages where I want. I can make some scaling to get it fit better. Then the front view, also same scaling to be done. And then I can adjust it to be aligned on the view below. Then the axiomatic view. There it is. Now it looks good. Then there are something that could be added is center lines of the pipes. I will activate those. And after regenerating view, you will see all the center lines where needed. And you can see also that the insulation is shown as a different line type. Then some dimensioning is needed. So I will define where these branches and valves are located. And dimensioning is added as with the same command that you are using at the 3D model side, and you will refer to the exactly same points. So if something is changed, it will be changed also here at the drawing. And this dimension here also, like this. Then I will place some labels. Those can be placed to one view at a time or all the views at the same time, and I can select several labels to be added once. And inserting labels is automatical, so just a little bit counting, and there it is. Now you can see at the top view that we have all the labels what are needed. Valve position IDs, pipeline IDs, and equipment position IDs are visible. Then I will make an export from this one first to the PDF, and I will view it immediately. Here at the PDF you can see that line thicknesses are extracted also here, so if I want, I can set, for example, that pipes are a bit thicker line, so those are seen more easily. Then next I will export to DWG. Here are also other formats that you can use, and I will use this our build viewer so that you can see immediately what it is. No need to other licenses. Here, if you check the equipment, we have here this layer available and all other layers in the drawing. And also, if query properties of this tank, you can find some attributes which are already filled at the diagram actually. We have this online collision control, which I did show earlier, but then we can also check the collisions later on. I will run this ready-made collision detection, and it will test what there is, and now I can query the result, how it looks like. Here is listed all the collisions what there is in the model. There is not any hard collisions, so there is not steel hitting another steel anywhere, but all those are something like pipe is hitting to the passage. I can search where this location is. It's showing it exactly that it is this elbow that is causing troubles now, and we should fix it. At the model, there is not visible these passages all the time, but I can activate those if I want. It's good to activate at this point so that I can fix this pipe more easily. So here is this error location. Just moving it a little bit, and there it is. Now there is no collision left anymore. Then this pipe does need some supports. I will add first primary supports to this pipe. Here and here by selecting it from the specification. There it is. And it can be slide same way as valves are slide. So I can adjust it to the better location so that it's easier to measure the correct place. Just by adding correct value here. Okay. Then the other support, same way I will slide it to the better location. Like this. Then I could move this pipe a little bit closer. Now it is 500 millimeter, but I can make this tighter, this place, by moving this whole set of the objects 200 millimeter closer to the pump. And same thing to the pressure side, just picking this corner and moving it to the same location as this other corner. And everything will follow. Now when all pipes are at the correct place, I can construct the secondary supports. First, I have to create 2 support groups where I will assign all the parts. First, I will assign these primary support, these groups, one by one. And then I will use the templates to create this support just by showing first point and second point. And because I use the templates, it's very easy to construct these supports. There is needed only to show this first point and second point. And here in the preview, you can see easily which are the points, what you need to point. And then in the model, you will just show those points. So same way this other support. First point from the floor and second point here the upper level, where to put the support. Here it is. That was our webinar today. So if anyone has any questions, I will happily answer for you those. If you need more information, you can find it from our webpage, and there is also describe better or more wide all our different products that you can use.